very similar. In fact, on some of the examples, I think you'll find that they look exactly the same. So first, we want to talk about execution environment. Now that I've asked you guys who have programmed in C# before, the next question that I want to ask you guys is, how about native programming languages like C, C++, compiled languages? Have you guys programmed in those programming languages before? C, C++? What else? I don't know what other code that gets compiled. No, yes? So the very first thing that I want you guys to have in mind when you look through the first two slides, so this one and the next one, is that in the programming world, there are, at least for the ones that you know for now, is compiled languages, which is what you see on the slide. And the next one is languages that run on runtime. So these are like C, C++, and these are like Java and C#. This one runs on the JVM. This is runtime. And this is the language. And this is the CLR or .NET. So I want to direct your attention to the slide. I hope everyone can see that. What you see here is the depiction of compiled languages. Languages like C, C++, where you would have the usual source code that you guys have to write for your homework, for your project, right? And then you have something which we call the compiler that compiles or translates the source code into machine code. When we talk about machine code, we're talking about assembly, okay? Assembly languages. I don't know if you guys, for the ICE curriculum, if you have to take assembly languages as one of your courses. I guess not, but that's all right. So since you guys have never taken assembly languages before, then I don't think that you have never seen machine code. And that's good, because one would never want to see the machine code. It's very tedious, it's not hard to understand, it's just very tedious, and it's not the usual language that we are accustomed to as human beings. But I hope that you guys are familiar with the source code, right? I mean, you should be. I found my target now. She doesn't look like I should be messing with her today, but you're not. What happened to your uniform? Huh? So what happens when you compile the source code? It gets translated into machine code, and the machine code is what the operating system understands so that the program that you wrote can be run on the computer hardware that you intend it to run on, okay? So from the behavior point of view, there's nothing different, okay? Just because it's a compiled languages, right? But it can just run and behave just like your Java programs. So what is the difference then? What is the difference between compiled languages and languages that run on runtime like Java? Well, the answer lies in the next slide. On the next slide, for this slide, okay, we are talking about Java or C# as an example. And these languages are what we call languages that run on runtime. If you compare, for those of you who printed out the lecture slides, if you compare the previous slide with the current slide, you'll see that the only thing that is different is that for this slide, you have an additional layer on top of the operating system, right? That is the only difference. So why the difference? You have to start thinking. Just like in any engineering solutions, you have to start thinking about why do we need to have this extra indirection or this extra layer. So if the difference is this additional layer, what do we do with that layer? You see, the operating system, right? If we view it as a module, Vicky, sit down. Please. So, if you look at the operating system as a box that takes in some input, right? What is going to be the input according to the previous slide? Can anyone help? Obviously, no one's listening, but so for those of you who are listening, my question is, the operating system as a module that takes in input, according to the previous slide, what was the input going into the operating system? No, not source code. From the previous slide, there was something on top of the operating system. Previous slide.
Machine code.
Machine code, right? So that ain't never changed. Just wear your lab shirt and then sit down. So the operating system take as its input machine code, right? So that's not going to change. So based on that fact, we can infer that the additional layer we have, which are JRE and Common Language Runtime, both of them must do what? Must output what? To be able to communicate with the operating system. The machine code, right? Because that's what the operating system does or expects as the input. So now that we know the output from these extra layer, okay, then can you guess what the input is going to be for JRE and CLR? CLR is Common Language Runtime, so it's the abbreviation of this. What is the input going into these runtimes? It's on the slide. Bytecode, right? Java bytecode, or in the .NET world, they call it the managed code. So you see, here's the point then. The point is that with these languages that need to run on runtime, on the runtimes, instead of the compiler compiling directly to the machine code, right, that the operating system expects, these languages compilers instead compile the source code and then turn them into what we call bytecode or managed code. So in other words, it's just an intermediate output to be fed into these runtimes. So you guys have to think now, what is the benefit of doing this? Like, why do you want to have bytecode? What's the point? Can anyone help me and try to explain or answer why is it that we need to have these extra layer? What's the benefit? And hint, we've already talked about this in some other slide. I think the first time that I introduced you guys to the JVM, the Java runtime, so many weeks ago. But does anyone remember, or can anyone tell me why? What's the benefit? Cross-platform, right? So what do we mean by cross-platform? This, right? Forget about the C# or the .NET world for a moment. But on the left-hand side, okay, when you have an extra layer, a runtime that's sitting on top of the operating system, the benefit that you get is that now the source code that you're writing is targeting some virtual machine, some machine that is called JRE. But the JRE itself will help take care of you by ensuring that the source code that you write will be able to run on those operating systems, be it Ubuntu, Mac, Windows, Fedora Core, or that's the Sun's, I don't remember. What is it, Solaris? Yeah. So the benefit of having an additional runtime, okay, of having a runtime is that it allows you to run the same code that you just wrote on multiple operating systems. That's the benefit that I want you guys to take away from this. Is that clear? That's the point that we're trying to tell you. So this is why for this slide we title it Platform Independence. So let's go back a bit, because since this lecture is about the .NET framework, I would now like to direct your attention to just the C# or the .NET stack on the right-hand side of the slide. And as I had mentioned earlier, just like how you have the JVM for the Java runtime, you have something called CLR, or Common Language Runtime, for the .NET runtime. And just like how we have Java, what we call Java bytecode, which is the output from the Java compiler, we have something that the .NET community calls managed code as the output from the .NET compilers. And the one unique thing about the .NET framework that I really like is that the creators of this framework allows you to also run unmanaged code. What do we mean by unmanaged code? Unmanaged code simply is code that talks directly to the operating system. In other words, it skips this step completely, entirely, and then runs on the operating system. So unmanaged code are code that get produced by languages like C, C++, right? These are, as I had, so let me write this. Unmanaged. And this is managed. And we'll see later today, okay, what's the benefit? Okay, what are the benefits of unmanaged code versus managed code? Before I go on, I want to point out that there's no such thing as managed code is better than unmanaged code, or unmanaged code is better than managed code. Each one of them has pros and cons. Okay, when you choose one, you have something else that you need to trade off of, and we'll point out those pros and cons later in the later slides. So the technical term of the output from the compiler for the .NET stack is called intermediate language. In other words, IL, intermediate language, is what you feed into the common language runtime. Okay? And then the common language runtime can take that and then translate it into the machine code that the operating system expects. What does the intermediate language look like? Well, as we see on the slide, okay, it is a low-level language that I hope that you guys never have to write, with simple numeric syntax, which can be quickly translated into native machine code. And the designer of IL, or the CLR, paid great attention into the quality of being able to quickly translate into native machine code, because later today you'll learn about just-in-time compilation. And that is the one thing that was unique, okay, and I emphasize was unique about the common language runtime was that it did not compile, when you finish compiling your program on the .NET, it doesn't compile the entire project into the IL. Okay, it only compiles the stuff that you actually need to run your application. So I want you guys to remember that for the .NET, IL, managed code, right? So IL, intermediate. That is the input going to the CLR. So we've already covered this. This is the mouthful that I always don't like that. And you guys, so on the JVM, you guys have been familiar with writing the Java language that targets the JVM, right? That's the only programming language that you know that runs on the JVM. One of the differences, one of the selling points of the .NET framework when it first came out was this feature, language interoperability. What does that mean? It means that for a single solution, like a single source code project, I don't want to say a single project because because that has a very specific meaning. So let's just say that when you create your programming assignment in .NET, you can actually have multiple programming languages working together in the same programming assignment. You're not restricted to just one programming language, just like your Java application. So what are the programming languages that you can use in the .NET framework? Well, the examples that we have for you here are just 3 of them. But as of today, I think there are at least 20 programming languages that run on the .NET. So, oh, I forgot to turn off my mail plane. So, as I had described earlier, the selling point for the CLR is that you can run multiple languages within the same programming assignment. Why do you think that might be good? Can anyone tell me why would one want to have multiple programming languages within the same assignment, in the same solution? Perhaps before I tell you or I get the answer from you, maybe if I had a motivating example where I ask you, why would it be good to be able to speak more than one languages? How many languages can you guys speak? Okay, well, you are in international school. 5? Okay, let's just have a concrete example. Okay. So who has traveled abroad before? Pi, where did you go? Japan? Oh, never mind, that doesn't count. Okay, let me ask the question then. Who has traveled to a foreign country that they can actually speak the native language? Okay, what country? Oh wait, but can you speak Thai? I think she can a bit.
I can hear. I can understand.
So she can understand some words, and that's good. Who else? Who else? Anirudh, where did you go? India? Were you able to converse in Hindi or? Did you find that to be quite beneficial? Did it make it easier when you got lost and nobody laughed at you for? So let's take Niran as an example, right? He traveled to India, okay? And if I compared him to me, if I were to travel to India, but I was not able to speak in Hindi, is it? Okay. Would it be, so who would have an easier time? Niran, right? So what's the point from that? Okay. When you're programming your assignment, if I ask you to pick between Java and C#, which one would you rather do your assignment on with? Java, right? Because you are conversant, you are proficient in that programming language. Now, let's assume that let's say, I don't know, Tato and I, okay, we have to work on the group assignment. But I don't know, and let's assume further that I don't know any Java. Tato knows Java, right? You're taking this class. And I know C#, let's say. For us to be productive then, it would be nice, right, if I can just program in C# and Tato program in Java, right? And you can see that that's the benefit, is that, see, in the real world, different developers sometimes have different proficiency, language proficiency. For a language runtime that allows for the same solution, okay, the same programming assignment to have multiple programming languages, that's a benefit when you have different developers of different skills. You see that benefit? So if I like to program so let's apply it to this example. If I'm good at C#, but Mederic is good at VB.NET, okay, and John Pot is good at C++.NET, each one of us can program in the programming assignment of our choice. Did I need to pass it to? Oh, you've already. Okay, so let's just, and then keeps. Ja. Oh God. So C#, VB.NET, and C++. See, now you make me lose, you make me lose my train of thought. Just one shout and I forget what I was going to say. So the key takeaway that I want you to take away from this slide is that the platform that allows you to program in different programming languages and yet combine it into the same project, that's a good thing. You can leverage different programmers' expertise and you can use the programming language for the right task. Now, I want to do it right for the Java or JVM community as well. On the JVM, okay, you can actually program you can use not just Java, but there are also at least 20 programming languages that run on the JVM runtime as well. Languages like JRuby, Scala, even, I don't know, I'm sure that someone tries to run the C#, try to make C# runs on JVM as well. Let me see. I wanted to point out something before we go on this slide. And I want to point out the .NET framework. Based on this slide, you would think that only Windows, you can only run the .NET on Windows. That is partially true. The reason why I say partially true is because there's another runtime that targets the .NET framework as well. It's called Mono. MONO. You can just Google it up, just type mono and then .NET. It's a runtime that works very much like the Java, the JRE, Java runtime. It allows you to write C#, and I'm not sure if it supports other programming languages, but I know for certain that you can run C# program on Mac OS X, on Linux, because someone created the mono runtime. So I just wanted to mention to you, there's not like a lot of significance behind that. Just to mention that it is possible to run your C# application on other operating systems as well, using the mono runtime. So what do we mean by language interoperability? Okay. What we mean here is that, according to the diagram, right, you have C#, VB.NET, C++.NET, where once the machine code gets translated, in your source code, you can actually call classes or methods written from another programming language. In other words, if you had created let's say, a class in C++.NET in a totally different programming language, so some class, right, in C++.NET, you can compile that, okay? You can compile that as a library. And then if you had another project, C#, you can make use of this library, which is written in another programming language. .NET, pay attention. And that's what we mean by accessing attribute, invoking method, instantiating object, is that even though you wrote, okay, you created a library in a totally different language, in this case, C#, C++.NET, but once you compile and build the library, you can actually use it in another programming language, like C# or VB.NET. This is what we mean by language interoperability. And we're going to find out, and that's not given, okay? Somebody had to create something to enable that. So we'll take a look at why or how they make that happen. But before we talk about that, let's talk about other things that the .NET framework actually provides you. Just like how the JVM provides you with a bunch of classes that you can make use of, like the thread class, what else? Applet, right? Swing, all those classes that came with the JVM. The .NET framework too provides something that are quite equivalent to those classes. The .NET framework certainly allows you to create threads. It allows you to create GUI, just like how you use Swing to create GUIs. And these are what we mean by .NET base classes. Classes that you can make use of, classes that you can extend from, okay? And the key here is that any of the languages that are targeted for the .NET runtime can make use of those base classes. So let's zoom in and look at the language interoperability. Okay, what can you do? So I gave an example, right, where we said that you can create a class or some library in one language and then be utilized in another programming language. In this case, we created something in C++.NET and then we make use of it in C#. Yep, because these base classes, they were built to be used by all the languages. Yep. Let's see who's talking. Ja. You can be generous, Naja, but can you keep your voice? Man. So, Ja, I want to know, I want to find out what you've learned so far. Besides, what do you have for breakfast today? What? So, Java, not Java, what are the programming languages that are available on the .NET framework? According to the slides, you don't have to tell me more than 3. Okay, thank you, Nai. And .NET, C++, .NET, and thank you, Nai. Well, at least Nai is listening. I hope you will be too. So I did not explain what we meant by utilize. Okay, what is a concrete example of using a library from another programming language? For example, on the CLR, on the .NET framework, oh my God, on the .NET framework, you can inherit, right? Extend the class that you wrote in another programming language and extend it to use it in the language of your choice. That's one example, okay? And I hope you guys remember the inheritance class diagram. And the key is here. A and B can be written in different languages. That's one. What else can we do? Where did I put my O? Another feature or another definition of language interoperability is that a class can contain an instance of another class no matter what the languages of the two classes are. And actually there's an asterisk to this statement. And I'll cover it in the later slide. But for now, I want to write the code to show the composition, right? I think you guys should remember this. So if we have class A, let's say that this is in C#. When we have composition, right, we say that, yeah, C. So this is what we mean when we say that A is composed of C, which is exactly that diagram. And the key that we want to you guys to take away from this is that C, as a class, can be either written in VB.NET, in C++.NET, and no surprise, or even in C#. That's the key that we want you to take away from this. So we've covered two things, right? We've covered inheritance. You can inherit from another programming language, and you can also contain classes written in another programming languages. An object, okay, can call methods from another object written in another language. This should be no surprise. If you can inherit, if you can contain classes written in another language, of course, you would want to be able to, you have to be able to call the methods from those classes, because otherwise then what's the point of inheriting, or what's the point of having them in your class, right? Containing them. Objects or references to objects can be passed around between methods implemented using different languages. Again, there's no surprise there, right? For example, if you have b.sum method and you had C is some reference from VB.NET, let's say, You want to get called, Nick? And B, this is in C#. You can certainly pass C as part of the argument into that method. So these are just like redundant examples, right? By redundant, I mean they're not necessary to be explained because the whole point is that you can basically use things from other programming languages as if they were written in the same language that you are currently using. So these are just examples, concrete examples, right? Inheritance, containing classes as composition, passing these objects from different programming languages into our method, right? These are the things that are very, we do every day anyway. But there's one thing that I want to point out, and this is actually not supplied by the CLR, okay? Which is the last thing. When debugging, so who doesn't know what it is debugging? Now, here, when we say debugging, we're actually being very precise. When we say debugging, so who programs or who tries to debug by using print statement? Okay, and that's good. I mean, we all need to use print statement, okay? I've never come across a programmer who has never used print statement to debug their program. It's probably the very first tool that is very useful. But you see, the thing about debugging using print statements is that you don't need to use your Eclipse. So the next question that I want to ask you guys is, Ping, so have you ever tried running your Java application from the command line, from terminal? Do you use Mac or do you use Windows? I don't know. Huh? Huh? No, you haven't? Maybe you should pay attention. So who has tried debugging or just running your program from the command line, from the terminal? No? So I assume that I understand that you guys have all just used Eclipse to run your program. Okay, maybe as a homework, I'll ask you guys to try running Java application from the command line. But it's very simple. It's conceptually the same, right? You simply have some .class file that is produced by the Java compiler, and then you type something like Java space the class name, and then it will just print out whatever that you want. Now, what's the point? Why did I want to talk about that? Because I want to set the stage to explain you different debugging, different interpretation for debugging. One can debug from the command line, using the command line. And one can debug using an IDE, such as Eclipse. When we say debugging here, we mean that you are debugging from or using the IDE and not the command line. And when debugging here, we mean that we're debugging from the tool provided by Microsoft, which is called Visual Studio, which I heard that for Juฬa students, you guys get the free copy of Visual Studio Ultimate, right? Can someone look up on eBay how much that costs to buy one license of Visual Studio Ultimate? No, forget Pirate Bay. Why would you want to download it for free why do you want to download it when you can get the legit license for free? Easier. You might change your mind when you find out how much it costs to buy a license of Visual Studio Ultimate. I'm not surprised why Microsoft is so rich. They charge exorbitant amount for just something that, it does a lot. How much, P? 600 pound. 10,000 USD? Really? Visual Studio Ultimate costs 10,000 USD. I guess I'll see a bunch of students run to grab their copy today. Anyway, point is, okay, 2,500 USD. You guys didn't know that, did you? The free copy that you get from July costs on the market, if you were a regular company or just average Joe developer running his own firm, 2,500 USD. So that's what? 70,000 baht. That costs a lot of money. Let me tell you a little story. When my first semester or my first quarter taking the programming class, my university gave out free copies of, back then it was not called Visual Studio, it was called Visual C++ 6. Visual C6 is the name. And back then, internet was not prevalent. It was not fast. We were still on dial-up. Okay, this was 9 years ago. Instead of downloading the program, we got an actual box, Visual C++ box that came with a CD-ROM. And one trait of engineering students is that they're quite witty. So the very first thing that we did back then was we got the copy and then we posted on eBay. So most of the students were able to get $300 to, I don't know, $400 or $500 for each copy, because I think the full price was $600-700, something like that. I'm just telling you the story. Nothing happened. We got easy money because we essentially just made copy of the CD-ROM. Back then, they just used CD-ROM too. I'm just telling you the story, that's all. You're not supposed to do that because it's a student license, but I didn't do it. I just used. Oh, back then, I think that it came with a manual too inside the box. The box came with a CD-ROM and a thick manual. Times change, right? Now everything you do, anything you do, you just download and get from the internet. Okay, the point, is when debugging, programmers can step between source codes written in different languages. So here, we mean that when you finally get your copy of Visual Studio, install it, you try to debug the program using Visual Studio. If in your project you had libraries written in another programming language, you can actually step into the source code and see the statement in another programming language. And you guys listening to this and you guys might be thinking like, what's the big deal? That is actually a very big deal because as a programmer, sometimes when you have inferior tools, it makes it very hard to debug because this is why the Visual Studio costs $2,500 as opposed to some other IDE where you can download it for free. Because I dare you to, get two libraries written in two different languages and then try to include into your project and then try to run it in some other IDE like MonoDevelop. MonoDevelop is another IDE where you can run your .NET project. It won't be able to show you the source code. So this is the selling point of Visual Studio. No. So here, I just want to say that first, this capability, what are the key takeaways? First, this is not provided by the .NET framework, this capability. It's provided by the Visual Studio tool that is provided by Microsoft. And that secondly, when we say debugging here, we mean that we're debugging inside the Visual Studio and not on the command line. Value type, the difference between value type and reference type variable. When you program in .NET, they make a strong difference between value type and reference type. For those of you who have programmed in C++, you are already familiar with this concept. In C++, you have two types of variables, as far as I can recall right now. One is a value type, and one is a reference type, or a pointer. What is the difference? It's very simple. Value type is simply that, some variable, okay? Reference type, on the other hand, is also a variable, but the value points to some other object. That's the difference. And you say, like, what's the big deal? It actually takes a long time to explain the difference between the two. Like, I think I can spend 10 minutes, and I'm not sure it might confuse you guys even more. But for now, just know that for the .NET framework, you will eventually come across the difference between value and reference type. And when you do, I just want you guys to remember the differences between them. One is value type that doesn't point to anybody else, and the reference type, which points to somebody else.
But we get the distinction in Java as well, right?
We do for the native type. Native type would be the value type, and then everything else, like when you have classes, those are all reference types. Right. But the one thing about the .NET is that you can actually pass to, when you pass some variables to a method, you can specify whether you want to pass by value, which is to not do anything, and pass by reference by putting the keyword ref, R-E-F. This is what we mean by .NET making a strong distinction between value type and reference type. And Java does not support that, because Java, everything is a reference, and you can't pass something by reference. Sorry. Let's just say that in C#, like, you can, denote whether you want to pass this as a reference or value type. Yeah. The next concept that I want to explain to you guys is strong data typing. And this is going to be quite difficult for people to understand. Who has programmed in, who has tried web programming before, like PHP? Or JavaScript? Who has tried JavaScript? Python? Ruby? This code here should make sense to you then. Vicky, can you explain me the point? Actually, can people help me and explain what is the point we're trying to convey on this slide compared to Java? Keep Java in mind and explain to me what the code is doing on the left-hand side. Okay, it is printing. That's the first thing. But I want to point your attention to the variable I. Phone. The first line, when we assign I equals to 8, what is the type of I? The type of I. What is it? Integer, right? Now, on the third line, Mil, what is the type? String. That's good. Now, my question is, if you were a head of a Java developer, can you do something like this? Where, wow, you guys are quite loud today, huh? You have int I and then suddenly you can you do something like that in Java, where you declare something as int I is equal to a, and then you have I equals to some string? Is that allowed in Java, Nit? Is that allowed? Why is that not allowed? Right. And right. What Nit just explained, and I'll repeat. She said that, look, this is Java, right? And she said, if you had declared some variable, okay, to be of some specific type, in this case, integer, you cannot assign some other type. In this case, hello is string type. You cannot assign string to be an integer. That is not allowed. What you see here is what I call the feature of strong data type languages. Strong data type languages are all these languages actually: C, C++, Java, C#. You can't do this in these strong data type programming languages. Now, let's compare this to another type of programming languages. PHP. So, who has tried PHP? Jae. Is that allowed in PHP? That script? That is allowed, right? So, in PHP, who's talking? In PHP, you can declare a variable as whatever. Okay, it's not really declaring. In PHP, the type of a variable is inferred based on the assignment that you assign to it. In this case, when you declare the $I variable, the I is actually just the I variable. The interpreter understands that, oh, you're creating an integer because you assign a number 8 to it. And then when you assign string to it, then it says, oh, well, now you want it to be of string type. And it allows for that. When you have this behavior in a programming language, we say that this is a dynamic typed programming language. So in other words, this is not allowed in Java, and something like PHP, where it's dynamic type. And this is strong typing. Strongly typed. This and this, PHP, right? So do you guys all see the difference? One of the differences between strongly typed languages, strongly typed language, and dynamically typed languages. The difference is that you can change for dynamically typed languages. You can reassign the type, not just the value, right? You can reassign the type of that variable. Whereas in strongly typed programming languages, you can only reassign the value. That is the difference. Now, anyone can memorize the definitions of, the difference between those two. But my next question is, can someone tell me the pros and the cons of each approach? I call it approach. What's good about this one? Just because I put an X right next to it doesn't mean that it's bad. Okay? I'm asking you guys, can someone give me some ideas as to what would be the pros and cons of this one versus this one? And what would be the pros of this versus this one? The first one should be pretty obvious on the dynamically typed, the pros of it. Can someone tell me what are the good benefits? Easier what? You have to explain, I mean, easier what? Okay, so Good said that it's easier to use. Can someone help explain a bit more by what we mean by easier to use?
Because we don't have to convert from one type to
Right. Well, first of all, you guys ever ran into that occasion where you're trying to convert from one type to another type in Java? And I'm not saying that it's actually easier, how should I say it? With dynamically typed languages, what it gives you is flexibility. So you can imagine, right? Instead of having to declare two variables, you can like reuse the same variable. But that's not really the selling point, but if you say that flexibility is what dynamically typed languages give you, what could be its downfall?
Runtime errors.
Runtime errors. Ja. And precisely what we mean here is that I've programmed in both strongly data type languages and also dynamically typed languages. And I can tell you that even though the dynamically typed languages give you more flexibility, such as allowing you to do this, but what the cost that you get along with it is that sometimes it's easier to mess up. And like when you look in your code, you have no clue what the type of this current variable is. This is why if you look at well-written code in dynamically typed languages, they have to name their variables very well to be self-describing. Whereas for strongly data type, you can see that it's a lot more rigid. Okay? There's less flexibility, but what it gives you is that compilers can actually help check for you your semantics. By semantics, I mean, I'm not articulating this quite well, but when you know for sure in each statement the data type associated with the variables, you can check, you can optimize your code better than dynamically typed languages, and it leads to safety as well. Oh, you guys are. Anyway, so the point on this slide is that I just want you guys to understand that the difference between strongly typed languages and dynamically typed languages is that dynamically typed languages allow you to reassign the type to a variable. So let's look at the benefits. Whoa. We've already seen that using this example, it's a bit more cumbersome to change the type of a variable. Right? So this is what we mean by cumbersomeness. Okay? It's more cumbersome to change the type, as an example. But what does it give you? And the key word is safety. Type safety. And type safety, which we'll discuss in the later slides, yield 4 benefits, which are language interoperability, garbage collection, security, and application domains. In the next slides, we're going to be looking at why. What do we mean by interoperability, garbage collection, security, and application domains? First thing, a bit more description of the language interoperability. In the previous slides, we've already seen that with language interoperability, you can do inheritance whose class are written in different programming languages. For example, A on the top left, A could be written in C# and B could be written in VB.NET, right? But you can still do inheritance. Or the bottom right left, A can also contain C, okay? But for these to work correctly, they have to know all the data types used by all the classes. So the question is, how does .NET achieve this? How does it allow two different programming languages to be used by one another? And the answer is CTS, or Common Type System. CTS is basically an enforcement. This is going to sound quite funny. To allow programming languages to play well with one another, to be able to talk to one another, you actually have to enforce or create another language, like a language specification conversion. And here's what I mean. I'll give a concrete example of CTS. In C#, you declare an integer by doing int. This is an int type, and you guys are familiar with this. In VB.NET, I think the int is like this. In other words, it's not lowercase I, it's capital I. If I wanted to use this int in C#, there's no meaning. There's no meaning behind that. So there must be something that translates between these two, right? If you wanted to use them together. And that mechanism, we call it CTS. Because under the hood, let's say that you are programming in VB.NET and you want to use something in C#. What happens is that, so let's give a concrete example. Let's say that we have a method. Let's say that we create a method inside C# called func, where it returns int, C# int. And I want to use this method in VB.NET. But we've already said that the keyword int with the lowercase I doesn't exist in VB.NET. So how would we be able to use this method inside VB.NET? You see, when this C# code actually gets compiled into IL, CTS takes care of mapping this and changing it to this. Because inside CTS, it knows that C#, there's a conversion like this. C# int is equal to int or VB.NET int. With the capital I. So this is an example. This is what we mean by common type system. All types that are supported by the .NET CTS, all the languages have the mapping to the common type. It doesn't matter if this lowercase I and that's capital I. In the end, they all get mapped and converted by the CTS to be the type that all languages can understand. And it's not just int type, right? There are a bunch of types that are available underneath CTS. Be it pointer type, class type, array, delegate, enumeration. All these types allow you to do more and being able to interop with other programming languages. But the most important key that I want you to remember is this example, I think. That internally CTS is used to map from one programming language's type to another, the equivalent in another programming language. And if C# had, let's say, 100 types, do all those types map to something in CTS? The answer is no. Only a subset of C# keyword are supported by CTS. So what's the, so if CTS is the tool, sort of like the underneath the common types that are provided by the .NET, what is CLS? CLS stands for Common Language Specification. It works, it works with CTS to ensure that language can interop. CLS is a set of minimum standards that all compilers targeting .NET must support. I've already alluded in the previous slide and saying that not all types provided by C# for example, will be supported by the CTS. So that means that whichever ones that are supported by CTS are the ones that follow the CLS, Common Language Specification. In other words, when you finally program in C# and you want to make sure that your code actually will be able to interop with other programming languages, you have to ensure that you follow the CLS. And let me give you a real-world example of some of the things that, as a C# developer, you must adhere to be able to interop with other programming languages. I think it was in Stack Overflow and CLS. Hold on, let me see. So what are the things that you have to do as a program developer? I want to give an example, like a concrete example. This one. If I had a class in Java or C#, let's say a class called foo. Is this allowed? So we have a method, func, and then we have this, func with all caps. Can you have two methods that contain the same name but different capital? Yep, this is in Java. Why? Because the Java programming language is case sensitive. So because of that, this is allowed. Good. Now, not all programming languages in the world is case sensitive. For example, VB.NET is not case sensitive. In other words, if you had class foo, and I don't know if this is the syntax of VB.NET or not, but let's just go along. If I told you that foo, okay, this is foo and func. Oh, sorry. I think you guys know where I'm going. So VB.NET foo and then func. If I told you that VB.NET is a case insensitive programming language, Would this be allowed? No, because to the VB.NET compiler, these two methods refer to the same method. You can't have the same method signature. Just like how you wouldn't be able to have lowercase func or two lowercase func methods. And if you look at the slide or what's on the screen right now, don't expose identifiers that only differ by case. The reason why is because like in the case of when you have VB.NET, this is allowed, right? But if you expose these two methods to case-sensitive programming language, it will not work. You see what I mean? So this is why we say that you should not publicly expose names that differ only by case, because you want to, because it would not work for cases when you have something like this, VB.NET, because these two, they refer to mean to the same thing. So I think I have talked a bit about this already, but if the green box represents all .NET features, for your programming language, this is case insensitive, right? So this language is case insensitive. So this is not allowed. This is allowed, so this is case sensitive. Yeah. This is allowed. But, okay, maybe I misspoke, but you have Java or C# that are case sensitive, right? If you publicly expose these two methods, you can. Right? You can. But the problem that you run into is that when you try to use these two methods in a case-insensitive programming language, it won't work because to a case-sensitive programming language, these are the same thing. I know. So coming back to CLS, for a compiler to produce, okay, to support a programming language that can be run on the .NET, it must support CLS or satisfy the CLS requirements proposed by the CLS. And a class, okay, can only expose CLS compliant part in order for other classes written in any other language to be used. And concrete example that I've shown you for the right box is this one, where we say that, for example, you can only publicly expose methods that you can expose something like this, right? You can only expose, if you want to expose methods, they cannot differ simply based on the case. But the key that I want you to take away is that for private methods or private member variables, those you can do whatever you want. Because those private resources will not be seen by external parties. On this next slide, we're going to be looking at garbage collection. Let me erase this. To understand garbage collection, you must understand first why we need garbage collection, what problem it's trying to solve. The simplest way to understand garbage collection is to link it to the statement of instantiating an object. Remember, we talked about this in instantiating an object. What may not be obvious to you is that each time you instantiate an object, it needs to reserve or claim some memory in the computer's RAM. So this is allocate memory. Has anyone ever run into some broken program that tells you that the Java, the JVM, runs out of heap space? Heap space. I ran into this when I tried to create the multi-threading example for you guys last week. But you guys can run into this this very easily when you try to allocate a very large array. That's how you cause heap space to run out. But let's come back to the main point. Each time you instantiate an object, okay, you guys know about computer memory, right? See, when you run an application, the operating system, well, okay, for this case, the JVM will give your process or your application some piece of memory that you can use. And each time you instantiate an object, it will grab space from that memory. So in this case, we have a bunch of objects in the program that have already been allocated. And when you new or instantiate a new object, what happens is that you claim some additional memory from that memory space. Okay? Now, we know that nothing is unlimited, right? Everything is bounded. All resources are bounded. So that means when you instantiate or claim some memory space from your program memory, eventually that resource must be released, must be given back. In Java, that process is called garbage collection. By that I mean garbage collections occur when the JVM wants to go through all the objects that have been allocated in the memory space and then reclaim the ones that have not been used anymore. Let me give you a concrete example. So let's say we instantiate A as an NAND type. You keep going along and hold on. So let's say that this is inside some function. Okay? At the very top of that function, you instantiate an AND object. And you merely run along, and then at the end you finish. The method terminates. At this point, if the garbage collector kicked in, it will see that, oh, A is not, this variable A is not being referenced by anything else. So it will reclaim that space. It will essentially free the memory that was allocated here. Is that clear? Anyone has any questions? So coming back to this example, right? We have a variable A, and then we have a loop that loops over, okay, many times. Each time, and each of the purple box represents free memory space. Each time that you instantiate an object, it will make this block unavailable. In other words, it claimed this memory block. So the white box represents memory blocks that is not available anymore. So when you instantiate the type A, that's the amount of space that the object A requires, okay? And then you can imagine what happens when you keep allocating, space. Eventually, you won't have any space left. So something must come to reclaim the memory. And that thing is called garbage collection, or that process is called garbage collection. And there are many different algorithms to do garbage collection, but you guys don't have to worry about that. There are two methods traditionally of how to manually to handle the allocation of memories. The first one, which is preferred by the traditional programming languages like C or C++, those programming languages, if you didn't use any of the standard libraries, they expect you to manually deallocate the memory. So you can actually do that in C# as well to manually deallocate the memory. So how do you manually deallocate the memory? If you instantiated the object A, it takes this space, right? You can manually deallocate by calling the finalize method on that object. So all objects in C# have the finalize method. And when you call finalize, essentially what happens is that it frees the occupied memory block, okay, away. So that's one method that you can do. What would happen if your programming language did not support garbage collection and you forgot to deallocate the memory? The problem that will happen is called memory leak. Reason why it's called memory leak is because you forgot it's leaking. In other words, memory usage keeps growing and you forgot to free or deallocate the memory that you're not using anymore. So in traditional programming languages, if you forgot to call something like finalize, you'll have a problem of memory leak. But language developers, or people like Anders Hallsberg or James Gosling, the father of Java, right? They want to make it easier for you to program and to avoid these mistakes. So what they did was they implemented what we call reference counting. Reference counting simply just each time you instantiate something, the object associated with it has a reference count of how many times this object is being referenced. So whenever you assign to a variable, reference count will be incremented by 1. Okay? And then when you're not using it anymore, the reference count will be decremented. And whenever it goes to 0, okay, that object will realize that, oh, I'm not being referenced anymore. And it will be marked that, okay, it can be deallocated now. How this translates into practice is that most of the time, you'll never have to worry about memory leak because garbage collection will be there to help prevent these problems from happening. Oh, it's 10:30. Hold on, we're not done. So why is it that strong data type is important? Because you see, each data type has different size. If you had class int that has one member variable, int a, and you have class b that has two variables, which class needs more space? B, because it has two member variables, right? And the point of this slide is that with strong data typing, you know exactly the size of each data type. So if you had int in here, you know that it needs one block, and if it was B, then you need two. Because it's strongly typed, you know exactly for each object how much space it occupies, and thus you can free it appropriately. You see what I mean? So this is what we mean by it is important to know exactly how much space is occupied by the object based on the known data type. Okay, so it's 10:30 and this is the next topic. Take a break and we'll start promptly at 10:40. And by the way, certainly we'll finish early today. And what I want to do is that I want to go over the homework and all the administrative stuff, but the remaining time, I will spend it on multi-threading because I felt like I rushed through the lecture quite a bit last time, and I want to open the floor for you guys to ask any questions that you may have. Because I've looked at the solutions submitted by a lot of students, and I can tell you that with the current submission of all the students right now, you guys will not get full points because it's not correct yet. For homework 7, multi-threading, the solutions that the students have submitted so far, those of you who have submitted, you guys will not get full points because the solution is not correct yet. It's not fully correct. And I'll clarify some things on the homework as well, some restriction. So we'll talk about that once we're done with the .NET lecture. So you guys can take a break and I'm going to start promptly at 10:40. Same concepts as well when we see C# for the first time. So on the screen, what you see is an example of what the Visual Studio could look like. This is what it used to look like, 3-4 years ago. 2008, so 5, all right. But today, when you download Visual Studio, the free version, Visual Studio Express, or when you get that copy from July, the Visual Studio Ultimate, it's going to look very different. And I have Visual Studio Express installed on my machine. Okay. So just like how you use Eclipse to program your Java projects, you will be using Visual Studio to complete your homework 8. So let's take a look at C# code snippet. Namespace is just like package, I think. Actually, I like the package syntax better. But let's not focus on that. What I want you guys to focus on is, can you tell me, can you list and identify the differences between Java and C# in this code snippet? Which one? The method name. For example, main, right? What's the difference between Java's main and C# main? Capitalized, right? The first letter. What else? String. So what's the difference between string? Java string and C#. Lowercase and uppercase. What else? What is very prominent? The method name. The method names are all capitalized, so that's the convention. But what is this code doing? Okay, it's printing. And what's the difference? Now, I don't mean qualitative difference. I just mean in Java, how do you print out something to the console? And how about C#? What do you use? Now, in your opinion, and I want to get your feedback on this, in your opinion, do you think that the Java's methods make more sense, or do you think that the C# one makes more sense? Why? Why do you say that the C# makes more sense? This is very good insight. Why? The wording, right? Think about it. If I did not know anything about Java, right? But assuming that I know something about console, system.out.println, would you know where that out is going to? Whereas here, it's system.console.writeLine. You see, now that I've dabbled in both Java and C#, I feel like in a lot of ways the C# founders, this .NET team, they were able to study the mistakes made by the Java developers or people who created the Java programming language, and they try to make things more pragmatic and make things make more sense. And I'm glad that you guys told me that the C# seems to make more sense, and I agree. And that's the point that I want to say is that, to me, when I read this code, I know exactly that it is outputting something to the console, or it has something to do with the console. Whereas for Java, you couldn't infer based on system.out.writeLine, println, right? So that's one, for example, one difference between Java and C#. Everything else should be pretty similar, right, to Java. You still have the curly braces, right? You still have return types. You still have semicolon to end a statement. A string is still a double quote, right, to denote a string. Double quote. You have semicolon. You notice now that method names are capitalized. Okay. And you have namespace, which is the direct equivalent for a package in Java. Okay. But you see, conceptually, everything is still the same. I mean, forgetting the namings convention, forget about semicolon, all that stuff. Essentially, everything's still the same. By that, I mean it is an object-oriented programming language because to do anything, you need to create a class.
The equivalent of system.console readline in Java.
That's a good question, and I don't remember. So if I wanted to read something from the console in Java, how do you do that? What's the command to do that in Java? Does anyone remember? Because I don't. How do you read a line in Java? You guys remember? Huh? Yeah, of course you can. So wait, I'm sorry that I forgot to mention this, but what is read line? What does this do? Read from input. Okay, specifically from what input? There are many sort of inputs, right? But read line specific has a very specific meaning, effect. Console, but okay, we're reading from the console, but what input is it waiting on? Exactly, it's waiting for the enter, right? Or I'm not sure if it's enter specifically or any keys. I don't know. I haven't run this application, but essentially it's waiting for the input from keyboard, right? Now the question from Tato, can someone help and tell me how do you do the equivalent in Java? What is the command? Scanner? So I think there's a scanner class, right, Joseph? Scanner class, and I don't know what the methods are, but I guess you can look up something scanner, and then you should be able to Google on Google. I mean, you should be able to Google for read line from console Java, something like that. I don't remember. I mean, this is why, as a programmer these days, Google is indispensable, no? So now that we saw the hello world example, now let's take a look at a more involved, a more complex application. Let's take a look at an application that has loops. So ignoring, okay, let's take a look, direct our attention to the for loop and ignoring the console.writeLine in the middle. My question to you is there any syntactical difference between the for loop in C# and Java? Is there any difference? If we were to just block out all the text and just focus on the for loop? No, right? And this is why the point that we want you to take away from this is that as a proficient Java developer, you should be able to look at C# code and make some meaning out of it. Let's test that theory. Who wants to be the brave soul and explain to me what this program is supposed to do? Oh, Niran just raised his hand. Hey, Niran, have a seat and you'll help explain. So Niran, I know that you are a very capable Java programmer.
Yes.
I learned that very well when you came to my office hour. So I would like you to help me and tell me what this program does.
Enter a positive integer, and we will enter integer after that, and then it will print the integer.
Good. Yeah, I mean, right? What do you think about his answer? He said it will enter a positive integer, and then you take in some integer from the command line, and then you print out the integers. Anyone wants to add to that? His answer is lacking in that it's not specific enough. But I mean, it is printing out integers, but what are the conditions for those integers? Can someone?
Actually enter a string, and then you convert the enter string into integer.
Right. And can you tell me which line converts from the string into integer?
Int and if or int parse s.
Right. Parse s. You see, good job. So right away, you see, some of you might think that, hey, when I read line, it should return me a number, but it doesn't. See, all things that you read from the console, even if you enter integer, it returns you a string. And you see an example right here where int32.parse is the method you use to convert from what to what. int32.parse is what you use to convert from what type to what type. String to int, right? Does anyone remember the equivalent method in Java? What do you use to convert from string to integer? Right? It was integer.parseInt. So those are going to be the things that you have to pick up when you start learning about C#. You see, you will still think the same way, right? You will still ask question, okay, now I need to convert from a string to an integer. But the question that you'll be asking is, I know that in Java I need to call integer.parseInt. Okay, what are the methods and what are the class names that I need to do the same thing in C#? So these are the questions that will be going through your mind. And you feel a bit frustrated sometimes, like, I already know how to do this in Java, but I don't know how to do this in C#. And this is the new experience. This is what we want you to experience. The experience of knowing how to program, I hope, but not knowing how to do it. And this is the whole point of this assignment. For those of you who have taken a look at and attempted to do homework 8, you'll see that it should be a very simple example. But the difficult part lies in the fact that you have to learn how to set up your C# project in Visual Studio. You have to learn all these new methods and APIs to accomplish the same thing had you been assigned a Java homework assignment. And this is why I'm pointing out these differences, little differences that you might have overlooked. Because when you start programming in a new programming languages, this is the kind of problem you'll run into. So there's not, much else. There's not anything else. So, by the way, I want to point out, so just like how you do an import to import the classes that you want to use in Java, right? In C#, instead of the keyword import, you use the keyword using. Okay? Well, not quite, but C# is case sensitive. So you can have two different methods that have the same word but different cases. And here we simply just showing you the different native types that C# provide for you. And I want to point your attention to the first two columns only, because everything else should be pretty self-explanatory. Let me check that hypothesis first. Ja. What is the difference between an 8-bit integer and a 32-bit integer? That's what you get for being so loud and not dressing appropriately. What is the difference between an 8-bit integer and, well, the answer is right there on the slide or on the printed slide. Did you print your slide today?
Yeah, that's what I
Ah, okay. Well, I hope can you tell me then the difference between an 8-bit integer and a 32-bit integer?
different types, different range.
Okay, can you explain in human terms what is meant by different range? Anyone can say different range, but what does it really mean? We are in international school. For now, I don't understand Thai. Can someone help her? By the way, I hope you dress appropriately next time, yeah? So, what is the difference between an 8-bit integer and 32-bit integer? She mentioned something about range. Can someone give me an example of what will not work with an 8-bit integer? Assigning what value will not work with an 8-bit integer? 128, right? 5,000 would an 8-bit integer work? No, right? Because, no, I mean, I'm explaining to you right now. Because an 8-bit integer can only hold up or can contain numbers ranging from negative 128 all the way to 127. This is why when Niran said, hey, try assigning 128 to an 8-bit integer, it will not work because there's not enough bits to represent that. Did you get that? Right? So the same thing when you have a 16-bit integer. Give me an example of a number that you cannot hold, that a 16-bit integer cannot hold. 2 to the 16, right? Because 2 to the 16, you don't have enough bits. So this is what we mean by the range. You see how it says, denotes it with min and max? That's the minimum value and up to the maximum value where it can actually hold. Can you assign a string to an 8-bit integer type? A string? No, right? And we also know that C# is a strongly typed programming language. Because of that, if you declare something as an integer, be it 8-bit, 16-bit, 32-bit, what have you, you cannot assign string to it. So I have explained you the description, I've explained you the range. Let's focus on the left two columns, and that is name and CTS type. Do you guys remember our discussion about CTS? Right? Remember how we had an example of where if you declared an int, right? Third row, if you declared an int in C#, CTS will map that type to be system.int32. Why? Why do you need to map that? Why did the .NET runtime provide need to have a CTS? We went over this. Right, so that you will have a common type, okay, that other programming languages can work with. Okay? So those are the significance of the first two columns. Left, the first column, name, are simply the data types that you have available in C#. S byte, short, int, long, byte, u short, u int, u long. Okay? And the second column shows you the equivalent type if once it got compiled and represented as CTS, CTS compliant, CTS type. And then we looked at integers, okay? And then you have other types. So you can see that the C# programming language is actually very rich in terms of the native types that come with it. So you have float, double, which you're already familiar with, okay? But you also have decimal, okay? And that is a very high precision 128-bit decimal number. Can someone tell me the equivalent in Java, the class in Java that can be used as a big, that works just like the decimal type in C#? No, not float. Double is right here. No, long is in the previous slide. The question is like, what is the Java's equivalent of decimal? I don't know if you guys ever needed to use it. No, float is already, well, you have float, you can declare float in Java, right? How about double? Double is double. Have you guys used the class big decimal? No. I think that should be the equivalent of decimal. So in other words, you can hold a very large number. You guys can verify that. I mean, it's just something that I wanted to sort of touch base with you. And then Boolean. What is the type in Java for Boolean? Boolean, right? But you see, C#, they realize, I mean, these are little things, okay? And these are my personal opinions, but if I had to declare a Boolean type, I would not call it Boolean, I would just call it bool. Because why do you need to, B-O-O-L, just like this. Why do you need to type all that out when you already know that bool stands for the Boolean type? What are the possible values for a Boolean? True, false. And char, right? You guys should be familiar with that. We have the direct equivalent in Java, and it is char, isn't it? Right? Characters in C# are Unicode by default. Not all programming languages are like that. And case in point are the languages that are very old, because back then. So what's the point? Why do we need to represent a single character with Unicode? What are we trying to achieve with Unicode? Yeah, why do we need to have char as Unicode?
Reaching the alphabet with the number.
Okay, reaching alphabet with number, that's one. The key is internationalization, to allow the programming language to handle foreign languages, and to be precise, non-English languages. That's what it means by foreign language. Not, like Thai is a native language here, right? But foreign language would be English. But in the computer programming world, foreign language refers to anything that is not English. You guys should already know these, but it's not really important. Okay, so now we have time for some examine real C# application, the ones that are a bit longer. So we have a console application example where this is what we're trying to achieve. The program is called RMS. Oh, I was going to upload the code sample so that you guys can take a look at. Remind me to do that. Let me see, write that down. I was going to check it into Git. So the first application we have prepared for you is called root mean square. Okay, you basically specify how many numbers you want. Okay, and then each number is input one by one on the console, and then the output will show you the root mean square based on all those numbers. So let's take a look at what it needs to do. So this is the pseudocode. You start the program on the left-hand side, initialize the variables you need. This should be pretty similar, right, to what you've seen before. What do you think this is called? You learned this in your first semester. What kind of diagram? Flowchart, right? Prompt for n, store n, prompt for a number, store the number. Have you reached all the numbers? Keep going, and then find RMS, show the result. So let's take a look at the code example. Hey, what happened? Hold on, okay? I thought my computer is. Question is for the people who use Mac. I'm loading up my Visual Studio right now. It takes a while because whenever you run something in the virtual machine, it always takes longer. So RMS program.cs. All right, first example. Now, can you guys in the back see? No, right? I need to increase the font size. I think it's tools, options, code editor. Source control text editor right there. I don't know if, no, I'm not gonna try it. Text editor, general, all languages, line numbers, we need that. How do you change the font? Let me see. Formatting. Maybe here. Font is text editor 14. Perfect. Is that better? Okay, so first my apology that I did not check this code into GitHub. I forgot. But like I said, so let's run this program first so that we see what it does. Whoa, wrong program. So this is Visual Studio, the program that I'm currently running, and I'm about to run the source code that you're seeing on the screen right now. Let's see what it does. I don't think you can see. Wow, I've used Mac for so long that it's... Okay, so you're supposed to enter a number. Let's say we pick 3. And then you're supposed to enter the next 3 numbers. So I'm just going to put 5, 2, and 1. And this program, what it does is that it takes the 3 numbers and then find the root mean square of that number. Okay, and that's all that this program does. So let's take a look how to implement that. So simply, you would just print out the statement that you want to as a prompt for the user, and then you would loop over, right? Yeah. So in this case, we're showing the do while loop, right? Then each time you would print out a prompt, read the line, and then if you remember, this is how you would convert the string to be a number, okay? And the try catch finally. This is I don't remember if Java has finally or not, but it does. Okay, so it's the same concept, and essentially each time, right? You keep looping. Oh, this is weird. Right? You keep looping, and then once you finish looping, then in here, you call the RMS method. Where the heck is it? Find RMS. When you finally finished looping the number, accumulating the numbers, you call the subroutine find RMS. So I think the very first thing that you see is that the source code is very similar to Java, with the exception of probably most prominently the APIs that you use to accomplish different things. Right? You should be able to just go through this and see that it's not that different from Java. So, parameter passing. So Tato, this is what I mentioned to you when this is a feature that Java doesn't have, and it is to basically pass something by reference into a function. And you denote that passing by reference by using the keyword ref. And the implication of this is that you can actually make changes to B in this example, and then it will be reflected when you normally when you in Java, right, if you didn't have ref, you pass y to some method. If you made changes to that y in the subroutine, that variable will not get updated. Okay, so let's say in this example, let's assume that we didn't have the reference keyword. Y is 20, right? You pass y into this method and you make changes. You assign 0 to that. In Java, when you print out y, it will still be 20. But since you can pass something by reference in C#, in this case, it will be changed to what? 0. So this is the difference between Java and C#. In C#, you can pass something by reference, and any modifications made to that variable will be reflected once the routine finishes. And that is done by the ref keyword. I think if I remember correctly, in C# 4.0, you can even specify what are the inputs and what are the outputs for each method to put as if like a label because the problem that you have when you have parameter that have like 5 different parameters is that you don't know which are the inputs and which are the outputs. With the C#, I think 4 or something, you can actually put along with each parameter which one is input going to that parameter and which ones are output coming out from that parameter. I don't remember the syntax anymore, but I just remember it's something that I have seen before. Oh. So this is just an example of passing by reference versus by value. And this is why we see that when you execute this program, if you try it out, you see that y, instead of being 20, it will be 0 because it gets modified in the subroutine. So we've seen how to do a normal, a simple Java program or C# program. Let's take a look at how you would define class as well as how you would do inheritance. in C# real quickly. And how do you specify all these accessibility, be it public, private, or protected? We probably have only public and private. Anyway. So I don't think there's a necessity or can't do that to run this program. What we should focus on is the syntax. Right? If you remember the UML diagram, yeah? Okay. If you remember, we had public class student, and deriving from that or extending from that is exchange student, right? So how do you do inheritance? Really easy. You simply just have colon instead of extends, okay? This is how you do inheritance in C#. And the way that you specify the accessibility is simply just prefixing the statement or the member variables with private or public, okay? And as you probably can tell, all method names in C#, they all capitalize. You capitalize the first letter. And that's what I want to just point out from here. Next slide. I think I've covered everything. Yep. Now that we take a look at inheritance, right, and accessibility, let's cover the last thing, which is interface. How would you declare an interface in C#? Open recent project solution tree interface. So how do you declare an interface? Very similar, no, to Java. You would just have interface, the keyword interface, and then the one thing about Microsoft or C# is that it's a convention that when you have an interface, you prefix everything with an I, capital I. It's not trying to be like Apple, okay? But it's just a convention. And you guys know that when you have an interface, you simply just provide the method signatures and no implementation, right? So so how do you implement such interface? Let's take a look. So if you remember from the, what do you call it? From the class diagram, yeah? You have tree, which is a class that implements the iGrowable, right? So you see here that we have the class tree which implements the iGrowable, but it uses the same syntax as inheritance. This is the reason why when you create an interface in C#, you would want to prefix it. Yeah, just to show that, oh, okay, you are implementing the interface, right? Because there's no distinction between implementing an interface and extending from a base class in C#. They use the same notation. So I'm going to upload this code sample so that you guys can take a look at what it does and try running it. Okay. So we cover that, and last thing to cover is composition. Tree is composed of branches, right? And you guys already remember, I've talked many times, when you have composition in, and how to express that in code is very simple. You simply just have member variables, See, tree contains branches. That's how you express composition in any of the programming languages. And that is all that I have prepared for this lecture. I'm going to upload the code sample so you guys can take a look and try to run these examples. And you can use them as references for your homework. The next thing that I want to talk about is the homework itself. I think that it shouldn't take you guys more than 3 hours at most. Well, I mean, so I just posted this last night, and instead of reading that, I'm just going to show you the application. So we call this application a balloon. When you run your application, this is what you should see, I hope. Simply just a circle, okay? And there are 2 buttons that your application should have. What do those 2 buttons do? Okay, when you press, one is a plus sign and one is a minus sign. So since this is a balloon, you can deflate or inflate the balloon. So when you press the minus sign or the minus button, it should deflate the balloon. And when you press the plus sign, it should inflate the balloon. So the balloon should, or the circle, I'll just say the circle now. The circle should become smaller or bigger depending on which button you press. And you should set a minimum size and a maximum size for your circle. And that's all that you have to do for this homework. Now, the requirement is that you must implement this using C#. Okay? You can don't submit your assignment with Java. Okay? So that's the requirement. So if you submitted your code with Java, you automatically get 0. Now, for extra credit, you notice how the circle the size keeps getting smaller even though I don't press anything in the demo. So since this is a balloon, okay, there could be some air leaks. And in this example, the balloon has leaks. So it will become smaller as time goes on. For those of you who want to get extra credit, you can implement this as well.
Extra credit for what? Sorry.
For this homework, so I don't know how many, huh? What if you want to get 10?
Well, if you don't do extra credit, you get not 10 already.
Yeah. So you will still get 100% on the assignment if you only implemented what I had described earlier.
But what's the extra credit for?
For this homework, so if you
already get full credit on the homework.
yeah, so we'll give you more, like I don't know, 13 or something
Okay.
out of 10.
แล้วภาษาที่อื่นได้มันstack up.
Well, I mean, this is assignment points. What do you mean no limit? We're gonna set the limit. What do you mean?
บางทีสมมติสอบระดับ95แล้วทำโบนัสได้อีก10เขาก็ตัดเป็น100%ไปแล้วไม่ได้ครับ
Oh, this is 150. Yeah. So this is real extra credit, okay? You will get more than 100% if you can implement everything correctly and do the extra credit. Okay? Jan, we have to check attendance too, right? Okay. ได้ครับ
So for this assignment, I think it's
good that Ja brought up that, well, she actually mentioned you has heard her loud voice, right? That she mentioned that we only studied C# for 5 minutes. Even though everyone knows it's 5 minutes, 5 minutes is actually the actual time that Ja actually pay attention. But, well, we have, well, Ajahn Sivakul, talk and go through some examples, some C# examples. But it's not quite extensive. It was extensive at all. Okay, it's just half an hour. But that's the intention of this homework. I mean, we will provide you. Actually, I'll post it in course view, but we will check that in the source code into GitHub again. Right? You have all the source code. Actually, the actions that is recommended for you for this assignment is as first, you find the tools, download the Visual Studio thing. Right? And it's probably perfectly fine to, well, load the source code. The last one, the tree. Have you shown the tree? Please show the program. Right? For this one, it is a C# with GUI. Okay? Then you have a button. And once you click this button, it just updates some states of your objects and then repaint the stuff. You can also think about the analogy of what will happen in your Swing program, right? It's the same thing. So for this homework, it's perfectly fine. Well, that you just open this project into your Visual Studio and fix the code. Right? Just adjust the code so that you obtain another button. Right? And then you listen to the events of the buttons and then just adjust the states of your balloons and then repaint the stuff. So I think 3 hours are probably spent, well, most of the 3 hours Ajahn Siva would mention will be spent on the time you're downloading the video. This should be probably done in half an hour.
Oh.
Well, but like I said, we are not intended for you to just go through start from scratch, right? Just open up the project, change the code of this one, right? That's all, right? That's the practice that we would like you to do. We are trying our hands on changing programming language from Java to C#. And you will see for yourself that even that you have learned, well, most of you have just learned or have seen the real C# code today. You'll be surprised that it's very easy to implement the assignments. Of course, you might run into some details that are different from Java, between Java and C#, but with the understanding you learned so far, it should be easy enough. That's probably all I want to say about the assignments. And I would like to just mention just simple, a short message about the project. Okay. Hopefully you have read the instructions. We are going to do something, not we, you. Are going to do something about a virtual world. We have provided the servers. We are done with the server, with all the service. Your project is that you are going to write a Java program that, well, work locally on your machines. Well, most of the effort you are going to spend is going to be on your JFrame applications, right? But it can talk or well communicate with the server in order to so that your program will be like a client or a portal that view the states of the world, right? But all the services are provided, and we have provided you a class that will be used to handle the communication.
Oh, so nice.
All right. Well, and what I have in my hands are the usernames and passwords of each and every one of you. Right? We have all the username and password for the world. I mean, you implement the programs that let the user log in to the world. But the databases are already, right? Every one of you has access already. Okay? And the usernames are all here. Well, the only thing missing probably might be, well, a program that lets you log in.
The only thing.
Username and password are all here, right? So
The only thing.
after class, Okay, please come visit the TA, and then the TA will give you your username and password, right? And I hope you go to Crossview and read more detailed instructions on the project, right?
All right. So let's get the administrative stuff sorted out and done. So I know I have to take attendance. So let's take attendance first, and then we have other stuff. Oh yeah, Ja, you know my throat is sore. What's the date today? 22nd. Ah, Ja, use your voice
Okay.
for something good for once. Oh, you don't need microphone.
อันนี้ไม่มาก็ไม่มาพี่ยศไม่มารุ่นพี่อ่ะไม่มาพี่ละพงษ์ไม่มาไม่รู้อ่ะไม่มาหมดเลยพี่ละพงษ์ไม่มา
Can everyone hear? Ja, can everyone hear her? Okay.
จอมพจน์
Oh my god.
ไรเนี่ยจอมพจน์เชเว่นอ๋อจอมพจน์มา
You know what? Maybe I should be the one checking this.
เชเว่นหน้าเห็นหมดเลยที่ร้านอัชชาเตมี
Temi. So, within a week, you're supposed to turn in what we call final project mock-up. Anyone not familiar with the term mock-up? Okay, we're gonna go over it. So, what do we want? The deliverable from you is a video. In that video, you will record and show us how your program will look like in the end. Are we asking you to create a program? No. What are we expecting? Details. You could submit anything as long as we, the grader, will see, have the picture in our mind what your program will look like. You can either do it as a PowerPoint slide, you can use Visio, you can draw, you can actually create like a mock-up Java program that just shows the program but doesn't really do anything. But what do we expect? The first and foremost, most important requirement is that it must be extremely, and I emphasize extremely detailed. It should cover all the aspects that your program plans to provide. What are those details? Things like interactions with the program. For example, you know that when you click on the About button or menu item, you're supposed to pop up a dialog to show, I don't remember, like your team members, your name, and what have you, right? Or how about the layout of your program, how it will look like, right? All these details we expect from your mockup, okay? So you have to put in a lot of effort into going through all the requirements and then create this mockup to show us your understanding of the requirement of what you expect, of what you are expected to do for this program. And we want to have the mockups for both the ICE the ICE port program as well as the ICE World Peak program. I hope that you guys at least know that you're supposed to create two programs, right? How will you be scored? As I had mentioned earlier, we expect that your mockup will be extremely detailed. Okay? It should go down to everything, layout, buttons on the screen, what it will look like, colors. We will judge you based on how much detail you can provide as part of your mock-up and how complete it is. Does anyone have any questions in terms of what we expect from you? Again, I would like to reiterate, I'm not expecting code submission. I'm not expecting some, cut up papers, some artwork. No, we're expecting video. อาจารย์อติวงศ์ครับ please.
Maybe it's possible so that we relax about the details of the appearance. I mean, we do expect layouts, we do expect interactions, we do expect events, but leave the details about the actual look, the colors, the shapes, the nice graphics, leave those details. But we do want to see layouts, we do want to see interaction events. Windows, pops up, things like that.
Man, you guys are saved by Ajahn Atiwong again. He's so nice, isn't he? So let me just reiterate, right? Like Ajahn Atiwong said, layout, buttons, interactions, but we don't, for the mockup, you don't have to do the looks of your program, the colors, all those stuff. It's all right.
What part of the grade will this be?
อาจารย์อติวงศ์ครับ What part of the final project will this be under? Is the grade for this homework? Is it going to go under assignment or is it going to go under final as part of final project's grade? Is that your question? Good.
We did not know. That's past tense. We could agree upon that.
So we'll make an announcement later after we've considered which part it should go to. But it definitely will go as part of assignment or final project. We'll make later announcement. Or maybe it's just free labor.
I believe, well, it's subject to our agreement, but I think understanding the requirements and make these first steps is very important. That's definitely gonna be part of the score. Okay, it's not 1 or 2 points out of 100.
So it's going to be
It could be 3.
out of 100. Hey, it's still point? 2.5.
I mean, because if you can remember, all the final projects we counted towards 20%, right? So I believe that this is a significant step in completing or in delivering your project. So it will count.
Just like Ajahn Atiwong said, yeah, view this homework assignment as a necessary step that you must perform in order for you to do well for your final project. Because if you don't think through the requirements, if you don't try to imagine what your program is going to look like, how can you create a program that will work ultimately, right? So this assignment actually we created to help you think through all the requirements. Now, this assignment is due a week from today, but the important point that I want to talk about next is the requirements. I want to say that you are not expected to implement every single requirement of the project. If you read carefully, right, in the project prompt that Ajahn Atiwong created for you guys, whoops. And we want so you see right here, we want you to not overlook this statement as it's very important. I don't want any of you to have the wrong impression that for you to get full marks on this assignment, you have to implement every single requirement. That's not true, right? Implement as many as you can, okay? But definitely it's not required that you have to implement every single one. We don't expect that, all right? Is that clear? So remember this well. You are not required to fulfill all the items. And that is all that I have prepared for to talk about in terms of the project. John Wong, did you want to have anything else? So now we have about 5 minutes left. I want to talk about homework 7, particularly multi-threading assignment. Who has not started? So far we have received 4 submissions, okay? And I want to quickly go over this homework because I feel like quite a few of you still do not understand what you're supposed to do for this homework. Well, it's going to take too long to clone the application, but I remember the code, so. See, for those of you who have checked out the homework already, you have a for loop. Was it? No. It was a while loop. While data available, you read data, and then you assign this to something. Let's call it data. Okay, data is equal to something that you read from the API provided by the Alien Communication Library, right? And then you process. You loop over, you have a for loop that loops over the array that is returned, and then you process one at a time. And then in the end, you output. For those of you who came to the office hour, I'm going to give you hints. I want you to realize that the data from this stage, okay, from this function call is fed into here. And the output from here is fed into here. That's the first hint. And secondly, I want you guys to think carefully about what's happening here. The for loop in the middle when we process. And I want you guys to think carefully how this for loop is related to the example we gave in class of how to sum 100 numbers. Specifically, how you divide up or split the work evenly. Example. Think carefully. The magic number for this homework is not 7, it's 2. There are 2 changes you need to make to this assignment that I look for. And one of them is not going into the jar file and removing stuff in there to make it faster. I'm looking at you, Putti. And I'm telling you that one of the changes is not going into the jar file and removing whatever they have in there and make it faster. That's not how if you did that, you would get 100% for hacking ability, but you would get 0% for this homework. So coming back to the main point, the while loop, okay? You essentially have 3 things going on within the while loop. You have the reading the data, the for loop that process that data, and the output. And here's the key. One restriction is when you read the data, this is neither thread safe nor can it be parallelized. In other words, the data provided to you by the aliens is sequential. You have to have only one, you need to have one thread reading or calling this method one at a time. You cannot parallelize this. So for those of you who created a master worker and parallelized the whole loop, that is incorrect. Okay? You can only read this one at a time. Only one thread can execute this. And these are all the hints that I can give you without giving away the solution. At first I felt like not giving you any hints. But I feel like now that I've looked at the examples or the code submissions, I feel like this is necessary to sort of guide you to the right solution. But it's not all bad, okay? There are some submissions that I'm very impressed with. Some solutions already got one of the two changes correctly. I haven't looked at all of the submissions, okay? But one of them already went to the right path. Think about the design patterns we went over in our homework, in the lecture, okay? So that's all that I have prepared for today, and it's 12 now. If anyone has any questions, I'd be happy to go over them after lecture. Remember, you want to write these down. For those of you who have not started, for those of you who are simply clueless, these are the hints that you can have for your homework 7. Thank you. See you guys next week. Hey, whose laptop?